connection to Facebook.com. It's traversing the internet with a public IP address that got translated at your home router facing your ISP. So where I live, we have Spectrum. So my router, my Spectrum router, is assigning, I think, all my computers 192.168.1. But when my computer communicates out, it's using the public IP address it's getting from the ISP. Okay, so we use a technology called network address translation to translate all those private IPs into public IPs. The beauty of private IPs, they don't have to be registered with any of the big, the number registrations like ARIN, right? Everyone can have the same private IP address spacing, right? And also provides an added level of protection against internet exposure. And then the key thing here, private IPs are not routable on the internet. So you may be wondering, well, how do these ISPs stop it? Like, what do you mean? Every ISP router or provider edge router facing a customer edge router is going to have some sort of filtering mechanism, ACL, if we're talking Cisco, right? That will always filter out Class A, B, and C private IP address spaces. Let's get into it, right? So Class A private IPs are going to be 10.0.0.0 to 10.255.255.255 to /8. Class B of private IP addresses is 172.16 through 172.31.255.255. And that's a /12. And then we have Class C, I think pretty much the most common one, your 192.168.00 through 255.255. These private IP ranges are what we're going to use for our private IPs. These always get translated to a public IP, and they're always filtered at the provider edge. Awesome. Pretty simple concept, and we will actually go over configuring NAT on our Cisco router to show you how we actually translate these private IPs into a public IP, and how it's possible to have 65,000 private IPs get translated into one public IP. Crazy, right? But it is possible. All right. Moving on. Now let's go over special IP addresses. So a couple IP addresses that are reserved and that can't be used or assigned. You have the loopback IP. This is going to be assigned to NICs, and it's going to be used to test the functionality of a NIC for IPv4. As you can see here, if you can go on your computer and ping 172.0.0.1, you have IPv4 functionality on your NIC. And a PIPA address. And a PIPA address is going to be a Windows computer or Microsoft technology that is auto-configured when your computer cannot reach a DHCP server. So if your computer doesn't get statically set or it can't reach a DHCP service or server, Microsoft computers or Windows computers are going to automatically assign itself in a PIPA, and here's the network range. So if you go to a device and the user says, I can't reach the internet, and you see this bad boy, DHCP right away, right? A PIPA equals DHCP not working. And this is an important range to know, 169.254. Every network admin should know that range. If it's going to be on the test, I'm not too sure. All right, awesome. So that's going to cover our IP address section. Stay tuned for our next videos. We're going to go over subnetting and the stuff we learned here about our subnet mask and our network address and the network bits and host bits is going to become very important. So I want to thank you guys for viewing this video, and stay tuned for our next.